Welcome, everyone, to episode 10 of the Community CloudCast. I am joined by my fellow host, Paul McCollum. Our other host, Jason Himmelstein, will be joining us a little bit later if he can. And we're also joined by our special guest of this month, Drew Minkin. Drew, welcome to the podcast, webcast,
Thank
whatever
you
we
very
call this
much.
thing.
CloudCast, I thought. Didn't we settle on that a long
Something.
time ago?
It's a something. It's a
It's what the
something.
logo says.
Yeah. If there's one thing I'm good at, it's reading.
From the slides.
Yep. Deck reading, it is a skill.
well played.
People say you
Well
should
played.
improvise and, not just read your slides, but I find it an art to just read my slides.
To just read the slides. Well, it's a niche anyway. So we are a week late this month. That is my fault. I had to go out of town for a funeral last week, so we had to reschedule. But Drew was gracious enough to join us this week and facilitate a change in the schedule. So we thank him for that. But normally we would be on our regular third Thursday schedule at noon. Of course, you can always go and hit up our YouTube channel for the replay on the broadcast. Leave us comments and whatnot over there as well, if you like. And we'd be happy to respond to you if and when we can. If you do have comments for our special guest, leave them there. We will forward them along and get you answers as soon as possible. So speaking of our special guest, Drew, how about a quick introduction of yourself?
I'm an Aries, and sorry, just
You like long walks in the park, and
right. Well, my throat may sound a little bit hoarse from teaching many weeks in a row, and also I have developed a talent in overtone singing, the hume. If you've heard of Soraya and some of the other, I think it was used in the Dune Sardaukar thing there. But I have a slide that goes into a lot of detail about me. But in my current incarnation, I work in the vet tech program, where it's like an extra GI Bill, where I take students that have had never been in the IT professions, and in 10 weeks, I make them, on a good day, data analysts, and on a great day, data scientists. So
wow,
it's pretty rewarding stuff. Yeah.
Wow. And that is primarily is that current serving or former?
It depends. I had a pretty good idea that things were going to go down in January, because I had a student that said that he had to pull from his resume because he was going to be a consultant on strikers with a Y, if you know what those are. They're somewhere between Bradleys and tanks. I had a feeling there was going to be something going down in Ukraine. But anyway,
wow.
So it's pretty exciting. It's a blend. A lot of them are retired. A lot of PTSD, a lot of TBI actually. When I was in startups, there were great successes for the company that helped nobody, and so it's nice to know that every day I'm seeing something that can impact generational wealth. So it's been very rewarding work.
Wow, that's fantastic. That's awesome. And that is Divergence Academy?
That's right. Divergence Academy. Yeah, based out of Addison. We're just starting up in-person instruction again for the first time post-COVID. So around Beltline and Midway. So
would that be a divergenceacademy.com? Is that the web address?
Divergence.1 is usually the link, but you'll see it on the slides.
Cool. Awesome. Very good. That's cool stuff. All right. So we're only going to do a quick bit of intro. Drew has quite a bit of information to share with us, and I'm excited to hear all about it. So just a quick thank you to our sponsors, of course, Aptigent, upcoming events, Initech that does not include a Share Cloud Summit, and I have the wrong link on there. I will fix that in the show notes. But that is coming up in Irving, the Thrive Conference in Slovenia, European Cloud Summit at the end of September. And it's important to point out that that is different than the European Collaboration Summit, which is Microsoft 365 and Teams focused. Cloud Summit is all about cloud, Azure, Google, AWS. So we'll have all the primary cloud vendors there. And it's a very diverse set of technologies, covers a lot more ground, as you would imagine, than the Collaboration Summit does. I think, in fact, tickets go up starting next week. So you want to get your tickets, get into those. It's in a beautiful part of Germany, right on the Rhine in Mainz, Germany, just outside of Frankfurt. Beautiful, beautiful little town. And like I said, right there near Frankfurt. And then Collab Days in Belgium. There'll be a few more Collab Days on the schedule coming up a bit later as we get them up and going. So Paul, quickly, do you have anything that you would like to share from a news perspective this month?
Yes, so there are a handful of Salesforce events going on around. My user group is back in person. I'll share a link to the Salesforce developer user group. We've got a couple of good speakers lined up for the rest of the month. Had a particularly good session last night with a speaker that swore a little bit more than I was used to, but it made for interesting. Yeah, it's powerful. And I have a new favorite label for his type of coding, and it's or his a problem solving, which is brutal.
Brutal.
The new complement. It's like heavy and brute force. It's attacking the problem with an axe as opposed to with a paintbrush. Or with a sculpting knife. It was he has developed his just destroying problems technique into almost a Zen philosophy. It was Sun Tzu and the art of motorcycle repair, I think, could probably be the but anyway, so that was fun. Texas Dreamin' is starting up, I think, today, tomorrow. Trailblazer DX is going on right now. There have been a lot of announcements in the Salesforce space, some fun growth around their training platform, just some more leaning into the gamification of it. Their declarative platform flows, which is kind of a Nintex-ish or Power Automate. They've got first order participation with Slack, MuleSoft, and Tableau now. So you can go out your workflows. Hey, I need to assign a case tomorrow. I can go out and pull analytics data to come back and make a decision on, who I should assign that to or where it should go next or stuff like that. So those Tableau, MuleSoft, and Salesforce or Slack were acquisitions, and now they're right-click automatable in Salesforce. So lots of.
And if you'd like to extend those declarative flows with almost 100 utility actions, www.aptogen.com.
Yep.
Check out our App Exchange listing. Thanks for the segue, bud.
Yeah, no, absolutely. And we had a good session on the CTA Saturday meetup with the guy I want you to watch. I actually forwarded him your talk on how to get on App Exchange because that's where they are. They are a kind of a middling provider, similar to just pulling and moving data around for event management. And they had built a Slack module. And so they've got it working for Slack and are trying to figure out how to sell it inside of Salesforce, where you can do a Slack, the console commands and say, give me the data about this person or search for anything about these people from this and have it bring it back into a Slack conversation or channel, publish and share. So I thought it sounded like there'd be some interesting synergy. I tried to work on an acquisition model for you, but I think I need to hand it off to you.
I'm ready. Tee it up. There's a commission in it for you. All right. As I mentioned before, Jason will try and join us a bit later in the session if he can. A couple of quick things on Azure news. Azure Purview, now in the typical Microsoft renaming cycle, has become Microsoft Purview. For those of you that are using that, I don't know that there are any features that were introduced, but it caught my eye on the list of notifications just because everything has to go from a product focus to a Microsoft focus once it becomes popular, right? Bring your own IP. has gone GA. This is big for a lot of people that are moving on-prem environments. We see this a lot in the SharePoint space, where you have pre-IP'd stuff and you need to do a complete farm stamp up in the cloud, and now you can bring your own IP there with custom extensions, which is pretty cool. One that caught my eye was the Synopsys Cloud, which is electronic design automation for silicon. So using the power of cloud capabilities to actually design silicon chips. All done in the cloud. It's pretty nifty stuff, sort of like AutoCAD in the cloud, kind of. I know people who do this stuff are going to hate me for saying that. I know it's more complex than that, but and then the final one that's I put on here because it drives me crazy is Azure Front Door, which is they call it a new Azure Front Door. I would like if they could just get it working properly. It's now offered in 2 standard and tier, standard and premium. Supposedly there's an enhanced rules engine. It's the rules engine that drives me nuts. So hopefully they're fixing that and making it better, because it ain't great. And there's not a lot of flexibility on the front end for routing rules and whatnot. So hopefully that's being improved. I haven't played with it yet. I just saw the announcement today. Enhanced analytics, anything that can improve this would be better. I'm sick and tired of traipsing through backend logs trying to find more stuff. Is that I should be able to pluck out a front door very easily. And it's not easy at all, or it hasn't been. So hopefully all of that is getting improved. So if you use Azure Front Door, I'd love to hear some feedback on if you played with these new features. I'm about to start playing with it soon myself to see if it has improved. But right now it's the bane of my existence. All right, so without further ado, because there is a lot of data to cover in big data, we'd like to jump in with our special guest, Drew, to cover his area of expertise. So Drew, I'm going to flip it to you. Take it away, my friend.
Thank you very much. Give me just a moment to share out my screen, and we will begin the show. All right, so big data has been around for half a generation for most people, but I would argue that we're kind of entering what I would consider phase 3 of its existence. And I'm going to help you understand why, even if you're not a company that is big enough where you've got exabytes and petabytes that have kind of already pushed you to that area, where it's very helpful to be able to be able to do what I would call big analytics in that respect. So I'm going to give you a basic understanding of big data as far as a positioning aspect, and understand what kind of problems it helps solve that are not necessarily just the scaling issues, and also take you through some live interactions after. I only have a dozen slides total, but we've got a good chunk of demos on some core technologies that will be very useful for anyone who's got data experience, be able to understand how the evolution of storage and compute have really, I would argue, been revolutionized from where things were even 10 years ago. So just some basic background. I mean, technically, I have been a CTO of a startup. We were strong candidates as being we were on the short list. Whether it's good or not, we were on the same short list as Cambridge Analytica at one point for a very large, recently public analytics company. And also another one that is IHS Market, that's a little bit more less nefarious. But I nowadays I'm focused on bigger picture stuff, and having the rule of thumb I would say for anybody interested in entrepreneur work is that make sure you're a founder, because there's a big difference between preferred stock and common stock when an exit happens. So we'll leave that pain point behind now. So in general, at its fundamental level, big data is about how do we handle an infinite scale, and there's a lot of interesting nuts and bolts about how name nodes and data nodes and how you interact with those layers. But let's just think of it being a magic, something that looks like a hard drive but could be 1,100 servers, as it spread across 1,100 servers with storage with the SAN behind it, as I worked with at AT&T. But the main thing to think about beyond just the technical nitty gritty of it, when there are workloads that require it, is that data movement is the #1 reason not to embrace, or basically, I'm sorry, data movement is the main thing to avoid in order to go through big data. The idea is that if you're going to do analysis, the old idea of doing ETL, going from one machine to from doing network copies and having different scenarios, it essentially came out of the need for data science being done on very large data sets, where it just became prohibitively logistically too much to be able to do all that work to be able to get stuff done. And nowadays, particularly with Web 2.0, and it's only going to get worse with Web 3.0, assuming that becomes something more than snake oil being peddled, for the analytics work, right? When you start looking at what people consider, some people say unstructured or semi-structured data for text and video and image and things like that, not having to be able to have a different infrastructure for what's being used live and what's being used to be able to gather insights from that live activity is the biggest bang for your buck. So I would argue that there's going to be an upfront hit anytime that you look at building a big data infrastructure, but in the long run, you want to make sure that you're that basically that what you're doing by making that investment is making it a lot easier to add incremental layers of value along the way with the life cycle of the data and your decision making there. And the biggest thing that's been a paradigm shift with cloud, with sort of second generation Azure, is the idea that compute independent of storage allows you to be able to just choose to use things, to have compute available when you need it. And so that's particularly in machine learning things where you have GPUs that are rented. It can be extremely expensive to be able to make those capital expenditures. So it fits into that sort of OpEx work that we'll be looking at there. So and again, I fell into coding from history religions. So I always think that it's very important to be able to spend some time understanding the history of how we got to the world we're going to spend time on. So essentially, out of everything that you see on this slide, the only two things that you will probably hear about for the rest of the the career these days are going to be HDFS as the actual layer of storage that is infinitely scalable. I've heard of their terabytes and exabytes are pretty common, but I've heard petabytes and even yottabytes people have. And then Hive itself is essentially the layer of being able to build a SQL query that can go directly against written files. And so, most people talk about velocity, variety, and volume being the big reasons to be able to bring in, to go to big data. I would argue that one of the two things that are much more common as far as a practical standpoint to think about, particularly in Hive and HDFS scenarios, is a schema on read concept that we'll see a little bit of today, and also the idea of write once and read many times. They basically go, because the idea is that you're trying that writes are the most expensive work that you can do now that you kind of move to one location for your storage there. So I just wanted to kind of give you some background on kind of some of the first generation. This is kind of a good slide for what we consider big data 1.0. But the reality is that even though this helped solve the data movement problem, there were a lot of challenges being able to have re-entrant work where, if you had a big job that was running and failed, you usually had to kind of start over again. It was very difficult to be able to have, it was kind of slow and clunky. And so there are some geniuses at Berkeley that started to look at a way to be able to take this core set of APIs and be able to build on it to build sort of what I consider, the next generation of big data, which is Spark itself. And we could spend a lot of time just going through. I could spend an hour on just doing demos of all these different scenarios as far as what is Spark. At the end of the day, there's this thing called an RDD, or a resilient distributed data set, which is the idea is that in HDFS, similar to like a RAID 5 parity, right? You have a file may not be stored in just one location in its entirety on one node to be able to make sure it's replicated. And Spark basically takes that basic idea and abstracts it into memory in that respect. So that RDD structure is that sort of parity or partitioned memory structure that essentially allows you to be able to have an infinite scale at the end of the day. So that's a layer, that's the big innovation that all of this other crazy stuff gets built on top of, right? Spark SQL and Hive, just to kind of let you know, are kind of potato. The syntax is extremely similar. In fact, it's practically identical, with exceptions that happen, of course, with vendor, dare I say it, lock-in, or their value add, reach versus rich, that kind of stuff. We'll see a little bit on Spark streaming, but that's the idea of having things like IoT hubs, Kafka, Flink, being able to be hitting a listener that's across multiple nodes in memory. So one of the beauties of it is that the line between looking at a streaming data set and a tabular data set really barely exists in Spark, and so that makes it extremely helpful for what people call a Lambda architecture, to be able to have a combination of serving from batch historical and live real-time data there. GraphX and MLlib, I would consider they're kind of the redheaded stepchilds of Spark in itself. GraphX is a lot of people might use Neo4j, or other emerging energies systems for doing graph expression. The nice thing about the reason why I like it's not as fast as a lot of other ones, but it makes it really easy to be able to flip between tabular and node based graphs, which is something that Neo4j doesn't do very well. And the best thing I can say about Spark MLlib, or Spark ML, I think is called. It's been renamed recently. Is that it does scale infinitely, right? But one of the things that people don't like to tell when they're trying to sell you big data is that big data is not always fast data. And for data sets that you can fit in memory, sklearn and other data sets, or other APIs are going to be a lot faster for ML. But if your data is that big that you don't have one machine you can put it across there, it's going to be easier to think about it along those lines. So Scala and Java are the only native APIs when it comes to getting the best bang for your buck in because HDFS and Hadoop and the infrastructure is all Java based. Scala is a functional version. It's kind of like the F# of Java, if you will. So it's a little bit clunky as far as its syntax compared to the sort of minimalist wabi-sabi of Python there. But they've made a lot of improvements in the PySpark ecosystem to be able to get native wrappers around what used to be called koalas, but now this Python library Pandas is essentially a native koalas binary infrastructure. That's kind of a nice introduction there. So anyway, so that's kind of Spark in a nutshell. But what's so we're kind of leaving the sort of core open source work, right? The people that were brilliant at Berkeley happened to raise over $10 million in their first round, which was more than my startup in the Spark ecosystem was able to raise in our 6 years that I was involved with them. I'm not bitter or anything, but they ended up making a company called Databricks. And so a lot of time they've done a very good job of making Databricks and Spark synonymous, but Microsoft is now ultimately looking at trying to build an infrastructure of its own using Spark that becomes, kind of its own way of branding things. So, so Spark itself is something that you can go to sparkapache.com or .org and be able to just spin up by yourself. You can even get all the fancy stuff with a little bit more elbow grease and Python to be able to work with. But time is also money in the business standpoint, and so there are reasons to be able to invest in good vendors. And Databricks and Microsoft have different interpretations and positionings of themselves that we'll be talking about as well a little bit there. So when we look at what Azure Synapse is, at the end of the day, it's really easier to think about it as a platform that has at its core a lot of Spark availability, and it touches a lot of other Microsoft Azure technologies in order to be able to integrate it into a much more robust ecosystem. Databricks, has done a tremendous job in being able to take, machine learning, data engineering, and the things of the sort of pre-Spark world and make it very easy and very compelling stories for machine learning and data engineering. But they are, basically, at the core, they built everything around their own version of Spark. And so they have one acquisition that we've done. We'll see very briefly in our demo, but Microsoft has a lot larger ecosystem that we're looking at here. So, when you see this ADLS Generation 2, that is basically Microsoft's branding of an equivalent of HDFS. When we get to Azure Databricks, or AWS Databricks, or Google GCP's Databricks, you'll see a DBFS, which is essentially a Databricks HDFS. So again, it's got similar metaphors as far as how you can interact with it, but we'll get a little bit of a taste of what that looks like later. But the main thing to understand is that at its core, there's a lot going on in Azure Synapse. There's also right now there's kind of a little bit of a tussle going on where Snowflake is trying to build Spark to be able to get the Python users and the PySpark users away from Databricks, and Databricks is also trying to up their game as a data warehouse engine, which is putting them at loggerheads with them. But in a lot of ways, Microsoft made the investment very early and found ultimately a good home for some things we'll talk about a little bit more later. But this just gives you an idea of sort of the ecosystem. It's going to be hard to be able to dig in too much into the product here, but I have a couple high points that I'll be showing you along the way. And when we look at the infrastructure for common data engineering applications, this is a scenario that is pretty typical. I would argue that you can look at Synapse. If you're looking at Synapse as far as the Spark pool, you could have something directly. Let me just add a little bit of a pointer here. You could add Synapse here and be able to put it in and read directly from here as well if you need to see the live stream, because a sort of Lambda framework, if you've heard that term, would be a combination of reading from disk and reading from streams to be able to build the reporting areas there. And I'm not going to be doing anything on ML in this particular scenario, but this gives you an idea of a very common type of overall solution to be able to look at. So the nice thing about Azure Synapse Analytics is it's basically an environment for doing Python work and SQL. You can actually do .NET coding against it as well, but I haven't I was in .NET 1.0 when it first came out when I was working at Microsoft, but I spent 5 years in the open source system. So I've become a Python convert, and I haven't gone back to .NET. So my tech leads will have to forgive me from Microsoft there. So anyway, so that gives you kind of a real quick tour of some of the major features that are different. So it's you know, I would argue that when you look at Azure Synapse, you're really looking at a big data 3.0 platform in that respect, where 2.0 would be kind of Spark, and you know, Databricks is trying to kind of move in that direction as well. So
okay, quick question, Drew. Have you been speaking English this whole time?
Well,
I caught Azure and Python and Microsoft in there, interspersed. The rest of it, I recognize the accent, but I think I may need to go to Divergence Academy. Is there a crayon level? Is there more of a pre-Vergence Academy, the Kindervergence Academy that I can join?
I think that, you know, I have some samples of code. I'm not that I can give you a voiceover so you don't have to translate on what they're saying. That I think will help make this a little bit easier there. But again, that's but you know, it's kind of hard to. This is a lot to fit into a setup in general. But you know, anyway. But yeah, I think my daughter once said that there are times that I open my mouth and she feels like bees come out. So I apologize. I did not simplify things enough there. But
yeah, for those of you concerned, we'll be rebroadcasting this later in English.
With subtitles.
With subtitles. Yeah, using the Comic Sans font.
Well, you know, I mean, you know, I think this was all set up so at least you had some. I think a lot of things will make a little bit more sense as we go through the demo here. So I think that it's appropriate at this point for me to switch gears. But if there's certainly any, there's any questions about what we've went over, you know, there's a, you know, when you look at, you know, I've been in the data in writing databases, have been sort of a computer professional for almost, I hate to say it, 30 years at this point. And, you know, big data is kind of the biggest paradigm shift besides the web that's ever happened in that respect. And, you know, it's, you know, there's a lot to the layers of it there. So, you know, I probably could have spent an hour just talking about Hadoop, but then we wouldn't have anything fun to look at. So anyway, with that, I'm going to give, while I'm starting up this cluster, I'm going to give a brief introduction to what a day in the life, or what Databricks is as an architecture, right? So at the end of the day, there is a, because Databricks and Spark are designed to be able to use storage that is independent from the actual compute infrastructure, and they basically charge by the hour for access to their environments. This is an environment where I'm basically setting up I'm starting up a cluster so we can run a notebook, right? Similar to what you would run into in Jupyter or Jupyter Hubs for a sort of shared workspace. This is an example of a series of notebooks that are part of the that have some samples from the Databricks Academy to be able to show some examples of technology that you can use in Databricks. And again, Databricks by itself, just if you look here, really sees itself in sort of 3 different modes, right? They acquired a company very recently where they've essentially got a Spark-based equivalent of SQL here. It requires like 8 cluster nodes to be able to start up, so it's pretty expensive to be able to run. What essentially allows you to do is have real-time the equivalent of something that would be independent of Power BI to be able to build direct SQL queries against any big data infrastructure, right? So you can think of this as this SQL product itself. You can argue kind of competes with Tableau or Power BI as being able to give you a layer of compute, but it's and visualizations, presentation, things of that nature. There's also an infrastructure for machine learning. One of the things that that Databricks as a company has done that's been a great service to the entire industry that didn't necessarily directly benefit them was looking at 2 technologies that they open sourced to be able to help solve different problems. One that I'm not going to be showing very much is this thing called MLflow, which was really the first mainstream API to have an analytic engine independent infrastructure, so you could manage experiments in machine learning that were happening at AWS or locally in Python or at Azure, and be able to kind of keep track of them all in one location. So that's sort of one of the markets that that Databricks is involved with. But the one that we're going to be talking about today is primarily looking at what's been an innovation in the data space called the Delta Lake format. And just to kind of take things back, most people think about databases storing things like how you'd seen a spreadsheet of there being rows and columns, and each literal page that's physically written is going to have a series of rows as a row store itself. And I think starting in SQL 2012 in Microsoft, they started to introduce the concept of a column store. This is also what's at the behind Bigtable in Google, and there's now an open source version called Parquet, P-A-R-Q-U-E-T, like the tile, the wooden floors, if you will. That was the darling of analytic work because it was an open source way that you could just query directly in SQL. But Delta Lake basically was created by Databricks and open source because they had a common engineering problem where people were trying to write to this one Parquet file and have multiple readers, right? When you're trying to centralize everything to big data, you essentially have a problem where if you have too many writes to the same file, you'd have problems, being able to manage that concurrency. And so essentially the Delta Lake format that we're going to go through a brief demo of here is an introduction to that type of that basically it's an extension. It's Parquet under the covers, but it adds another layer for transaction logs, or the equivalent that I think could show you some examples. I'm sorry, what was the question? All right, so I think our cluster, our cluster's up right now. But just to give you an idea before we, since we're, this particular cluster is the simplest one that we have. It's not that big compared to how big they can get. But if you look at just some very basic things here, high concurrency would be for when you're running jobs for when you're doing, research work, and you appealing in Databricks is that they have great algorithms for knowing when to spin up the number of workers to be able to make sure jobs finish very well, right? So, and there's a lot of cool stuff I could go into just on talking about clusters, but just wanted to give you that sort of basic understanding of this layer between the storage and what we're looking at here.
I always thought the worker algorithm was based on the available balance on my credit card. At least that's how it seems to work in Azure.
Well, yeah, that's where the max workers comes in, right? And also that's why anytime I do it, I choose single node, because if generally speaking, 14 gigs, and 4 cores. I mean, that's not a bad system, at least for dev, right? I mean, when it comes to production work, that's when it starts to get expensive. So anyway, but all right, so let's actually start looking at a notebook here. And I'm not going to go through a lot of the nitty-gritty of this here, but have you guys talked about Python, or I mean, sort of Jupyter notebooks or notebooks in general previously in your talks?
Sorry, I was on mute. No, we have not.
Okay, all right. Well, I'll explain that because there's even though this says Python at the top, the way that notebooks work, whether Zeppelin was the original big kind of big data notebook architecture, and then Jupyter kind of leapfrogged over it later. And Databricks was early enough to market that essentially their proprietary notebook system, it imports Jupyter, but essentially its code base is based on Zeppelin. So this percentage run is essentially the equivalent of having a command line shell into the worker node, or I'm sorry, the driver node, or the main like the where the primary node that you're connecting to in the cluster before big jobs get distributed out, because you still got to connect to one location there. And so this is essentially what's cool about this is that this is actually telling it that it can go here and run this notebook. So you can essentially tell it to run a notebook from using this magic commander. So you can kind of in Jupyter notebooks, you can interleave between command line shells and Python, SQL, Scala, what have you. And are
you limited in those notebooks to specific types of operations in order, like you have to do writes followed by reads, or can you just sort of mix and match all those commands and it auto optimizes?
Oh, well, I mean, auto optimization is done in the query processor of the Spark engine, what creates what they call the DAG, or the directed acyclical graph, the equivalent of like the execution plan in SQL terms. So that optimization is kind of built. That's a set. You can tweak it and hack it the same way you can add hints and things like that. But basically, this is you can think of this equivalent, this percentage run, and this notebook system as the equivalent of batch scripts that can each run individual queries.
Okay. Just real quick, want to welcome Jason, our fellow host, and the only one who probably understands any of what Drew is talking about out of our group. Well, thank you, Jason, for joining us and adding some intelligence to this conversation.
I did bring Nate with me, so like Nate, my cat, is sitting here in the chair. I just got out of a meeting at work where he decided to lock the computer because he was done. So he stepped on a key and locked the machine, and he's I
think Paul locked up after Drew's intro.
Yeah, I mean,
just watching the bouncing cursor.
Well, it'll start when we get to SQL queries, it'll start to make more sense. You'll be like, oh, okay, I think I can follow you there. So anyway, briefly, and actually looking at the time, I don't even know if I'll try to go through this real quickly here. Let me just do a run all on this, and then I'll just talk about. There we go. While it's running, we'll talk about it here. So basically, this data set has these 5 columns in it here, and this mount that's equivalent to an MNT in Linux or Unix is essentially a shared file that's being connected to our cluster in this particular case. But it might be a DBFS, HDFS, ADLS, what have you, or any Azure block storage as well. So all that's happening in this place here is that one thing that's really cool as a general concept in Spark is that schemas can exist independent of a file themselves, right? So, it's kind of similar to in SQL Server how there's a type that you can build that exists independently of an actual table, so you can use it in sort of something like that. But what's cool is that it's essentially, it can, the beauty of big data schemas is that they're designed around a JSON format. So they support array and object structures for essentially what we would kind of look at in canonical pre-big data terms of nested files in that respect. So you can see that this is Spark here because behind the scenes, Python itself has a different memory system than the Spark memory, so everything's kind of bouncing back and forth. But what I want to point out is that once you make a connection to Spark, you're getting an RDD like I talked about. And here we're reading from a stream that the data is coming in from, but that could be from a file instead of a stream. So like I said, the line between streaming and files is very, very light in Databricks terms. And so so this is basically just setting up the Parquet file and the checkpoint, but together that basically you can look at that the subset of what the Delta format is this Parquet columnar format here. And the checkpoint is where it keeps track of actual writes that are happening. And then this is just naming a stream that we'll be using to be able to write connections that are coming in, right? And so this is, since I ran everything at once, this stopped the actual streaming, but you can see the batch records that we're running through. You could kind of insert Kafka, Stream Analytics, Flink, whatever you wanted, as a way to be able to bring data into what's being written to a table in this particular case, or a file, however you look at it. So, as you can imagine, when you're writing to a file and you want to keep track of the exact granularity of what's happening in that file as a separate checkpoint scenario, you can have bloat in that checkpoint file. And so this is essentially, you can see an alter table, right? That's a SQL command, right? It shouldn't be too.
Now we're talking language. Now I can
see. I told you it'd start to make sense at some point, right?
I understood that reference.
I know. But like I said, basically everything that you used to think about below the SQL command is the gobbledygook that's new, right? So the idea is basically this says, okay, look, I'm going to basically be querying the transaction log instead of writing it to the Parquet file for 10 days, right? You can actually do a vacuum later as a way to be able to bring that in, but we're not going to do it with the vacuum later at this point. So, and so this just shows you some of the details of what comes back, as far as showing the properties of the particular table that we're looking at here. And so now we have a select. So this is, because we're using Python as a wrapper around Spark SQL, right? You can see that we're passing in as a variable the name of the table, but we're doing a count star from it right here. That's select count star, right? We're back into SQLville. So this is where we start to add new things that are sexy that you don't have in your other dialects of SQL, right? This is sort of the Databricks Spark SQL exclusive that ultimately I predict Transact SQL will support, right? So this describe history is, because describe is the equivalent of like looking at the information schema. It's kind of an optional aspect to have the equivalent of the information schemas of tables and columns in big data, because if you write a file that's got 5,000 columns, sometimes you only need 500, and that's the table you're looking at, right? So it's a little bit more loosey-goosey, but this is basically showing all the actual timestamps of when things actually hit writes on the file that we're looking at here as an example. And then basically here what we're doing is we're getting that result programmatically, and then we're taking the we're taking the first two and going to the second to last one with this -1 here to basically create the first timestamp, right? And so so then what we're doing at this point is we're saying, okay, even though if I do a select star here, I'm going to get 96 like we saw earlier up here. If I had the timestamp as of at that point, it'll tell me what my count was at that particular time, right? So I didn't have to do, we specified the schema once at the beginning, right? We didn't do any mumbo jumbo with change data capture or audit logs or anything that would take this offline to be able to interrogate what's happening in the database. But it gives us that analytic window because we have essentially you could look at the Delta Lake itself has a transaction log that is implicitly queryable. So that's pretty sexy stuff in my opinion. Because as a data engineer, there's a lot of hoops you got to jump through a lot of times to get that kind of detail there. So anyway, so that I thought was a good kind of introduction to help you understand some of the core work of what Delta Lake is, but just to kind of help you understand some of the other things from a database standpoint here. So anyway, I know that was a quick bus tour and we don't have too much more time. But what I want to do is just briefly talk about, so this is something we kind of get in, let me move to Synapse because I know we're running out of time here. So as an example here, if you look at what is in Synapse, right? We'll forget about all the lovely cool things about having the equivalent of integration services or its new format, Azure Data Factory, as something that may look familiar to how control flows and data flows look like in the ancient past. But from a SQL pool standpoint, right? Because Spark has a Spark SQL native environment, basically what's happened is that Synapse allows you to take Transact SQL as an engine and that dialect of SQL and be able to use it against Spark jobs. So you can interleave doing Python and SQL work in Azure the same way that you would in in Databricks. So there's two worlds that that exist as far as how you can build these SQL pools, right? The one that's the closest cognate to how Databricks work is what we consider serverless, which means basically it spins up nodes as needed to be able to have you run the jobs, and then it has magic to be able to decide how well they'll run. But the one that's kind of near and dear to my heart, having spent a lot of time in data warehousing and also having spent time at a startup that was based with the same investors that sold, albeit potentially prematurely from Microsoft's opinion, the engine that was one point known as parallel data warehouse, and then the SQL DW product, and now is essentially what they call the dedicated SQL pool. That's why I named it DAT Allegro Lives here, is that this has some special extensions that I have optimized the SQL engine for scale out to be able to handle typical data warehousing work, things that are kind of being hacked back into Databricks and Spark in general that Snowflake already has, right? So just to give a quick example of that part, since I want to leave a couple minutes for questions at the end here, I'll just point out that that you see this syntax here about how the distribution is handled, which is essentially a way of being able to decide, okay, if I've got 50 nodes that I'm scaling a table out to, how do I handle putting those into different locations as far as which node does that data reside on, right? Another advantage that the dedicated SQL pools have that you don't have in any other Spark engine is being able to say, okay, look, this is a dimension table, so I want it essentially copied to all my locations, so that way I don't have to do any crosstalk to be able to get significantly faster work. So essentially, you get sort of the best of both worlds of having the Spark, on-demand work, and also have some very deep kind of data warehousing infrastructure that's worthwhile here. So yeah, all right. So anyway, just to give an example of, I'm not going to run this because I want to leave a couple examples, but you can see that, this is an example of a Python that you can run against one of these the Spark pools here. And if we look at an example of how SQL on read, or how schemas on read works, right? This is an example of basically just being able to create an open row set, right? That's a syntax that's been around since SQL 7, but being able to hit it directly with a format to be able to read from big data, kind of the evolution of the polybase architecture there. So with that, I want to leave, I see we've only got 5 minutes left. So I certainly could go on, but I want to see if there's any other questions or any other highlights. As far as I got one slide left that we didn't really cover, so let me just start there. Just as far as to to look at kind of the summary aspect, right? I've tried to make the case that Spark and big data not only solve the problem of data movement, but they also make it much easier to manage being able to have the types of AI workflows and other types of advanced analytics that you need to be able to quickly. Databricks has done a tremendous job of gathering the mind share of Spark, but they've recently contracted Bill Inman, for those of you who he's sort of the godfather of data warehouses, to help steal mind share from Snowflake. So they're right now, those two companies are loggerhead at this point. But in a lot of ways, while those two duke it out, Azure made the investment in DAT Allegro already to be able to take good advantage of those places, and they also have a lot richer ecosystem for integration parts of that. So I know that this is a lot of very data intense jargon that we've pulled out, and I've tried to unpack this as much as possible, but by the same token, there's some things that just can't be simplified much more sometimes. So
yeah, I'm sorry you didn't have time to go into anything complicated.
Well, I tried to. I didn't even get to the complex stuff on this simple stuff. So
yeah,
but
started with incomprehensible and ended with time travel.
Well, if you're gonna
clean segue,
go big or go home, right?
Yeah. The only thing I didn't understand was everything that came out of your mouth.
Yeah,
so,
to be fair, Drew, that's not unusual. Talking technical. Paul just sort of smiles and nods, which is what I've been doing.
I'm the looks of this
really
operation.
Really well. So, yeah.
Well, look, I data itself is not the sexiest, from a business perspective world, but at the end of the day, it's something that needs some unpacking, but sometimes people, I guess that's why they pay you the big bucks to not have to unpack it in front of the board. So there's that.
So as someone who has a SQL background, and I don't do the data stuff like Jason does all the time, and even Power BI is sort of stretching my comprehension of report building, but I am used to working with really large data sets in a relational database and trying to massage that into something useful. How do I, with a basic background in databases, take this next step and start to learn how I can enhance those solutions with the type of things you're talking about? Where do I go to begin?
Well, Microsoft has done a really good job of building examples, similar to Transact SQL, of where you can at least get the basics, right? At the end of the day, when you think about, you still get the beauty of Transact SQL for the most part, as far as, if you go to books online for SQL Server, you'll see that, almost all of the syntaxes that are the same for your developer edition of Transact SQL are the same for a SQL dedicated pool. What's different is the storage underneath it and whether you need the Python angle, right? Because, I would argue that it was data science that created the need for big data because they wanted to be able to do very complex analysis that required big feature engineering. And it got to be too expensive to try to make copies of that data other places. So for core SQL, it just becomes, you have the exact same tool set that you had previously. What's changed is how you can scale everything underneath it in that respect. So there is kind of, I wouldn't call SQL a kiddie pool compared to Python, but from a data science perspective, right, complexity wise, SQL is much more tractable than trying to do unstructured deep learning. So.
Well, unfortunately, that's all the time we have for this particular episode. There was a lot there. I hope you all got something out of it. I learned a few things. I'm going to have to watch it 3 or 4 times to, I think, learn the rest.
Yep, on slow speed. and look up stuff like crazy. So yeah, I'm going to burn a hole in Wikipedia later tonight, I think.
But Drew, we can't thank you enough for doing this with us and helping us. We spent our first 9 episodes staying away from Jason's core topic. We finally got to a topic that is in Jason's side of the field, and unfortunately I had to miss half of it. But in any event, we will be revisiting the data and big data question in future episodes. Want to thank our sponsors, of course. Want to give a shout out to the Bifocal podcast, where they talk more about things like this. It may be in language that Paul even understands. And of course, Paul mentioned his user group that's here in Dallas for a Salesforce developer user group, which met yesterday, I believe. But is it the 3rd or 4th Wednesday? 4th Wednesday of every month?
4th Wednesday of every month. Yes.
All right. So with that, we'll wrap it all up. Thank you, everybody, for joining us for this episode, and we will see you next month again right here on YouTube and Facebook. Bye, everyone.